Imagine looking up at the sun, a familiar, life-giving star we often take for granted. But our sun is not a quiet, unchanging ball of light. It's a turbulent cauldron of nuclear energy. Sometimes it erupts, sending colossal waves of energy and matter into space. In 1859, the Carrington Event sent a powerful solar storm to Earth, sparking telegraph wires and shocking operators. Today, our world is far more connected and far more vulnerable. A storm of that magnitude now would be a global challenge, testing our resilience and cooperation. We live in a cosmic neighborhood that's active and sometimes chaotic. Understanding these forces isn't about fear, it's about knowledge and preparation. This knowledge empowers us to protect the civilization we've built. So let's explore what a solar superstorm is, how we can see it coming, and what it would mean for us. This isn't a story of doom, but of resilience, science, and the human spirit. It's a chance to understand our star and how to safeguard our future. When the cosmos presents a challenge, we have the capacity to rise and meet it. Let's begin. 15. What does the sun throw at us? Plasma, a superheated electrified gas, the universe's most common state of matter. The sun's magnetic fields can snap, launching a billion-ton cloud of plasma, a coronal mass ejection, or CME, into space. The sun is 150 million kilometers away. Light takes 8 minutes to reach us, but a CME can take as little as 15 hours. This travel time is our window of opportunity. Unlike earthquakes or tornadoes, a solar storm announces its departure. We can see it leave the sun. This lead time, whether hours or days, is crucial for preparation. Think of the sun as a cannon, a CME as the cannonball. We can't stop it, but if we see the flash, we know it's coming. We can calculate its speed and trajectory, giving us just enough time to brace for impact. This ability to foresee the event is our greatest advantage, a testament to science and observation. How do we know a storm is coming? We have robotic sentinels in space, satellites like SOHO and SDO, watching the sun 24/7. They monitor sunspots and magnetic fields, looking for signs of eruptions. When a solar flare erupts, its light and X-rays reach Earth in 8 minutes, our first alarm bell. This flare can disrupt radio communications, but it's also a signal that a CME may be on its way. Using coronagraphs, scientists track the CME's size, speed, and direction. If it's aimed at Earth, agencies issue warnings to power companies, governments, and satellite operators. This prediction system is a triumph of human ingenuity, a celestial weather service millions of kilometers wide. We can't control the sun, but we're no longer its unsuspecting victims. Our ability to watch, analyze, and warn transforms a potential catastrophe into a manageable crisis. 10. Once the warning is issued, the countdown begins. Our satellites are first to feel the storm, vital for GPS, communications, and weather forecasting. They're vulnerable to high-energy particles. Next, the internet undersea fiber optic cables are safe, but their electrical repeaters can be fried by geomagnetic currents, risking widespread blackouts. On the ground, the storm attacks our power grids. Shifting magnetic fields induce massive currents in transmission lines. Transformers, the heart of the grid, can overheat and fail, leading to long-lasting blackouts. This cascade starts in space, moves to the internet's backbone, and ends with the collapse of our electrical systems. Without electricity, modern life halts. No lights, water, fuel, or digital transactions. Society could be thrown back to a pre-industrial age in hours. Understanding this sequence is the first step to mitigating damage and planning our response. Could Earth's atmosphere be blown away? No. Our magnetic field and thick atmosphere protect us. While a solar superstorm can rattle our shield, it can't strip away our air like it did to Mars. Humanity would survive, but the challenge is restoring our technological civilization. Recovery would require global cooperation and months of repair. Communities would need to rely on local resources and ingenuity. The good news: we can prepare. Power companies can install protective devices and stockpile spare transformers. On a personal level, having extra water, food, and a hand-crank radio can make a difference. This isn't about panic. It's about foresight and resilience. This cosmic challenge is also an opportunity to build a more robust infrastructure and invest in science. By learning and advocating for smart planning, you become part of the solution. The universe isn't always calm, but by understanding the stars and working together, we can ensure a bright future for humanity. 13.